This lecture will be dealing with the basics of trigonometry. Now, trigonometry is a chapter in which we will be relating the ratios of the sides of a right angle triangle with the acute angles of the triangle. So to do that, first we need to recognize in a right angle triangle what are the different sides and what are they called. So I'll draw a right angle triangle. So I've drawn a right angle triangle which is A, B, C, and it is right angled at B. Now if I ask you, out of the three sides AB, BC and AC, which side is the hypotenuse? It's the most easiest because it is the longest side. So I'll denote the hypotenuse by H. So AC in this diagram, in this triangle, would be known as the hypotenuse, since it is the side opposite angle 90 and it is always and also the longest side. Now if I ask you, in this triangle ABC, which side is the base and which side is the perpendicular, there is a small trick involved in it. There are two acute angles in this triangle, angle A and angle C, and depending on the angle we pick, the choice of perpendicular and base will change. So initially, out of the two acute angles, I'll take angle A. Now for angle A, I need to recognize which side is the perpendicular and which side is the base. Now perpendicular is always the side in front of the angle. So for angle A, the side in front of it is BC. Therefore, for angle A, BC would behave as the perpendicular, which in the diagram I'll denote by P. So perpendicular is basically the side in front of the angle. The second is the base. Now AB, which is just adjacent to the angle, this becomes the base. So AB becomes the base because base is the side adjacent to the angle. So we see here that hypotenuse is the longest side, which is opposite angle 90. Depending on the angle that we pick, the side in front of it becomes the perpendicular. The side adjacent to it becomes the base. So here we have chosen angle A. For angle A, the side in front of it was BC, therefore BC became the perpendicular, and the side adjacent to it was AB, and hence it became the base. Now this would change if we change the angle. So next I will be picking angle C. So if I draw the diagram once again, so I will draw the triangle A, B, C once again, which is right angled at B. This time I would pick angle C. So I'll write for angle C. Now AC would automatically become the hypotenuse because it is the longest side. Therefore AC remains the hypotenuse. However, as we have seen earlier, the perpendicular is the side in front of the angle. So for angle C, AB is in front of it, hence AB becomes the perpendicular. Therefore AB becomes the perpendicular since it is directly in front of the angle C. Now BC, which is adjacent to it, becomes the base. Therefore BC becomes the base since it is adjacent to angle C. So as we saw earlier, the choice of perpendicular and base depends on the acute angle that we pick. For angle C, the side in front of it was AB, hence it became the perpendicular, and BC became the base. While earlier we had seen that for angle A, the side in front of it became the perpendicular and the side adjacent to it, AB, became the base. We move forward to the next topic, which is the topic of trigonometric ratios. Now, trigonometric ratios would be the heading where we'll discuss how we can relate the ratios of sides with the angles. So I'll again take a right angle triangle A, B, C, which is right angled at B. Now I need to have a ratio between the sides, hence I need to first pick a angle. I'll pick the acute angle A. For this acute angle, I'll mark the hypotenuse, the perpendicular, and the base. So AC has become the hypotenuse, BC has become the perpendicular, and AB has become the base for this angle A. So the first ratio that we'll see is known as the sine ratio, which in short form is written as SIN. It is the ratio between the perpendicular and the hypotenuse of the particular angle. So for angle A, the perpendicular is BC and the hypotenuse is AC. Therefore I would write sine of A, because I need to mention the angle. Because if the angle changes, say we had angle C, the choice of the perpendicular and the base would change. Therefore sine of A is equal to the perpendicular for angle A is BC and the hypotenuse is AC. The second trigonometric ratio is known as the cosine ratio, which in short form is written as cos. It is the ratio between the base and the hypotenuse. So for angle A, the base is AB and the hypotenuse is AC. The third ratio is known as the tangent ratio. In short form, it is written as tan. It is the ratio between the perpendicular and the base. Therefore, tan of A would be equal to the perpendicular for angle A is BC and the base is AB. Now these three, the sine, the cosine and the tan, are the three basic ratios. The remaining three are reciprocals of them. So one by one we'll start with reciprocaling each one of them. So we'll start with sine. The reciprocal of sine is known as the cosecant ratio. Its short form is cosec. It is the reciprocal of sine, hence it is hypotenuse upon perpendicular. Therefore, cosec of A would be written as the hypotenuse is AC and the perpendicular is BC. So we can see it is the reciprocal of sine. The fifth ratio is the reciprocal of cosine and it is known as the secant ratio, and in short form it is written as sec. it is the ratio which is reciprocal of cosine, hence the ratio between the hypotenuse and the base. So for sec A, the hypotenuse is AC and the base is AB. The last ratio, which would be the reciprocal of tangent ratio, is known as the cotangent ratio. It is in short form written as cot. Now cot is the ratio of the base to the perpendicular. Therefore, if I write cot of A, now the base is AB and the perpendicular is BC. So you can see it is the reciprocal of tan. Now these ratios would have changed if I would have changed the angle. So next I will be changing the angle, but you can see that mentioning the angle is very important, because based on the angle the choice of the perpendicular and the base would change. So what I will do is that I will again take the triangle A, B, C, right angle at B. This time I will take the angle C. For angle C, AC would certainly remain the hypotenuse because it is in front of 90 degree. AB would be the perpendicular since it is the side in front of angle C, and BC would become the base since it is adjacent to it. Therefore sine of C, I am mentioning that out of the 6 trigonometric ratios we just saw, the first is sine. Sine of C, which is perpendicular upon hypotenuse. For angle C, the perpendicular is AB and the hypotenuse is AC. The second ratio would be cos of C, which is base upon hypotenuse. For angle C, the base is BC and the hypotenuse is AC. The third ratio, the tangent ratio, tan of C, which is perpendicular upon base. This would be the perpendicular being AB and the base being BC. The fourth ratio, which was the reciprocal of sine, which in short form is known as cosec, the full form being cosecant. Cosec of C, which would be hypotenuse upon perpendicular, the hypotenuse being AC and the perpendicular for angle C being AB. You can see it is a reciprocal of sine. The fifth ratio being the reciprocal of cos, which is known as sec, mentioning the angle C, which would be hypotenuse upon base. This is AC upon base, which is BC. And the sixth ratio, which is the reciprocal of tan, cotangent, is cot of C, which would be base upon perpendicular. What is base upon perpendicular? The base here would be BC and the perpendicular would be AB. So what we saw as depending on the angle, the choice of the perpendicular and the base would change while the hypotenuse remains same. Hence mentioning the angle in front of the ratio is very important. And these ratios have related the lengths of sides with the angles.